Hey guys, it's Tuesday. Happy St. Patrick's Day. And with apologies to First Block because I did share this joke on Friday, but I thought it was a good one since today is St. Patrick's Day. I hope you get a chuckle out of that. Hope everything's going well with you and that you're able to stay on top of all of your assignments. So here we are at day 2 of coronavirus break. I decided to add the answers to yesterday's homework to this video. So if you notice, this was the homework that you should have completed yesterday and hopefully sent me an email. Well, I've got the answers for starting with number 7 through the rest of those problems right there. So if you'll check those out, we're not gonna be together, so we won't have that homework review time. So from this point on, I'll make sure I supply the answers for you. So if I go ahead and move forward in today's, all right, here on these two right here, we get an opportunity to actually do a little extra practice. I provided answers for those. Here's the actual assignment that's going to be due tomorrow, homework number 2. And aside for 1, 2, and 3, which are way too easy, I've given you the answers for all of these as well. So you can check your work. Now, obviously, I'm looking for the work. I don't need just the answers. So these are not the kind of problems you can just look at and go, okay, yeah, number 4, I can see the answer is x equals 12. Well, show me how you got x equals 12. So show me the setup on all of these. But I did provide you answers. I thought that would be helpful for you. I'm kind of working on this, how I can give you a chance to ask me questions in a live format. So there's a possibility I might be able to come up with a way that we can do that. But for right now, obviously you can text me through Remind, and I can help you through a problem if there's something you don't understand. All right, so here we are, day 2. This is Tuesday morning, Tuesday's assignment. We're going to look at similar polygons, not just similar triangles, but similar polygons. We'll kind of zone in on triangles at the end here. But similar polygons are polygons that have the same shape, but different size. They have the same shape, but they have a different size. Go to Walmart, look at their don't go to Walmart right now. Go to Home Depot, look at their boxes. They have extra small, small, medium, large. These are all rectangular solids, and they are similar in shape, but their sizes are different. So we're talking about just 2-dimensional shapes. Polygons are similar if 2 things that are important. The corresponding angles are congruent. All right, so that's a big key. So just like with congruent figures or congruent polygons, similar polygons, their angles are still congruent. So for instance, let's say that we have a right triangle like this, okay? And maybe this bottom angle is 60 degrees and this top angle is 30 degrees. And we'll be studying these kind of triangles a little bit later, a 30, 60, 90 triangle. But then perhaps you have another smaller right triangle. Well, that bottom angle can still be 60 degrees, and this top angle can still be 30 degrees. So those 2 triangles would be similar to one another. So their corresponding angles are congruent. But what about their sides? Well, obviously they're not. But they do have a relationship. They have a mathematical relationship. Corresponding sides are not congruent. Corresponding sides are proportional. Proportional. Now, what do we mean by proportional? Corresponding sides are proportional. Well, that means that the ratio of the sides, if you're comparing the small side, the small triangle sides to the large triangle sides, or the large triangle sides to the small triangle sides, those numbers can be written in the form of a ratio, and that ratio has a name. So the ratio of corresponding sides is called the scale factor. factor. The scale factor. And scale factor is, you can see scale factor on all kinds of things. If you ever did model airplanes or model cars as a kid or anything like that, they will have a scale factor often written right on the box telling you what the scale factor is. In other words, like maybe the parts on that model plane or model car are 1/32 of the actual plane or car or whatever. So that's telling you what the scale factor is. So that ratio of corresponding sides is called the scale factor. Now, when we say corresponding sides, we're talking about if we're comparing the bottom of this triangle, the base of this triangle, this short leg, to this short leg, or the ratio of the hypotenuse of the large to the small. So corresponding sides. If polygons are similar, then their perimeters are also proportional. In other words, the distance around those figures is also proportional. And guess what? That proportion is going to be the same as the scale factor. So let's talk a little bit more about scale factor per se. Scale factor is a ratio, all right? So don't get freaked out about that. It's just a ratio, just like we talked about in yesterday's lesson. So in looking at these two triangles, it says, what is the scale factor of triangle ABC to triangle DEF? Well, let's take any one of the sides. So let's say I'm going to take side AB, okay? Well, side AB compared to side DE. Now, you may be looking at that going, how did you know to compare those two? Because they happen to be in the same position? No, because those are the sides that are between the angle that has one tick mark and two tick marks, and the same one down here has 1 and 2. So those two sides, AB and DE, are the corresponding sides. So that's why I chose those two. So we can take those distances, write it as a ratio. So 8/12, all right? And of course, we know we always want to reduce these. So 8/12, these are both divisible by 4. 8 divided by 4 is 2. 12 divided by 4 is 3. So the scale factor of this smaller triangle to the larger triangle is 2/3. Now, does that only work with those? Well, no, let's take another one. How about 14? Okay, 14 divided by 21. Is that 2/3? Well, 14 and 21 are both divisible by 7. So if I reduce that, guess what? I still get 2/3. Coincidence? I don't know. Let's take the other two. Let's take BC and EF. All right, 10/15. Well, those are both divisible by 5. And guess what? That's going to be 2/3. You see what's happening here? So the ratio of all of the sides of the small triangle compared to the large triangle, those are proportional, and the scale factor for that is 2/3. So look at the next question. What's the scale factor of triangle DEF to ABC? So in other words, now we're going the other direction. We're going to compare the larger triangle to the smaller triangle. Well, if we start with our first two again, that's 12/8, and that is going to reduce to 3/2. So now you see why these two words are over here. Order matters. So when we say the scale factor from one triangle to another, it very much matters which triangle is first and which one is second, because that's going to determine what goes in the numerator, what goes in the denominator. All right? Well, we can do the same thing with the other sides, 15/10, 21/14. Those would both be 3/2 also. All right, last question right here. What is the ratio of the perimeter of DEF to the perimeter of ABC? Okay, the perimeter of the big triangle to the perimeter of the small triangle. Well, let's take those and see. If I add these three values up, that's going to give me the perimeter. That's going to be 27 and 21. That's going to be 48. So 48 over the perimeter of the small triangle, which is 18 and 14. That's going to be 32. Okay. Well, let's see what's going to happen with that. What goes into both of those? Well, 16 goes into both of these. 48 divided by 16 is 3. 32 divided by 16 is 2. And voila, check this out. The perimeter of the scale factor and the perimeter of, the ratio of the scale factor and the ratio of the perimeter are the same. I should say the scale factor. Let me say the ratio of the scale factor. The scale factor and the perimeter ratio are exactly the same. So if you know the scale factor of one figure to another, guess what? You also know the ratio of the perimeters. So that leads us to something very important down here, similarity statements. A valid similarity statement must match corresponding angles and sides. Not surprised by that, are you? After all that we've talked about with congruency statements and matching up the letters and getting them in the right order, it only follows that this would be true as well. So there's a symbol for similarity. Similarity just uses that symbol. And again, the name of that, I think that's referred to as a tilde. It's probably got another name in computer lingo. But it is the similarity that that's the symbol for two figures that are similar. So what we're saying right here, it says, write a similarity statement for the two triangles above, okay? Now, when I write the similarity statement, it doesn't matter which one goes first or second. So I'm going to say triangle ABC is similar to triangle DEF. And again, what allows me to say that is that all the sides are proportional and all the corresponding sides are proportional and all the corresponding angles are congruent in these two triangles. All right, let's list all the congruent angles and write a proportion that relates to corresponding sides. So check this out. We got two triangles. Triangle JKL is similar to triangle PMN. So we have three angles, three sets of corresponding angles. These are going to be congruent. All right, and again, let's start on the left. So angle J is going to be congruent with angle P. So they're going to have the same measure. They're going to be different sizes. They are different sizes. But we're saying that angle J right here and angle P have the same measure. All right? K and M. So angle K congruent with angle M. So K we're going to put two tick marks on K. We're going to put two tick marks on M. And the last one, angle L, is congruent with angle N. So let's go three tick marks on those two angles. All right? So we have three pairs of congruent angles. All right, remember what we said. The sides, though, are proportional. Sides are proportional. So again, we can really follow the similarity statement up here and not really have to look at these two triangles to figure out what these are. So what we're saying is that if I compare the first side, let's take JK, this side of the triangle, JK divided by over here, side PM, okay? That ratio, the ratio of JK to PEM, this way, is going to equal the ratio of KL. So I'm taking the second and third over MN. And that ratio is equal to JL divided by PN. So that proportion just simply says that those three, if I had numerical values for these fractions would all equal, these ratios would all be the same. All right, so that's a really important page. If you need to go back over that again, just hit rewind so you can hear that explanation one more time if you need it. Let's move on. All right, number two, we've got two triangles. This time, the two triangles that we're talking about are X, Z, and this Y. So the entire figure is proportional to this smaller triangle. And you got to be careful with figures like this. It's real easy for your brain to segment these and say that this little triangle, small triangle, is somehow proportional to this little, really was probably a trapezoid, okay? Be careful about that, all right? It's the entire shape is proportional or is similar to the smaller triangle. So again, just use your similarity statement up there to write these congruency statements and the three proportions. So we're basically going to have three fractions equal to each other down here with the sides. All right, so let's do the angles first. Again, I'm looking right here. This is what's important, okay? So eyes on that. So angle X is going to be congruent with angle R. Angle Y is going to be congruent to angle Y. That's a big shocker, isn't it? We're saying that this angle, Y, is congruent to itself. You get it? Because angle Y is in both triangles. And then angle Z is congruent with angle S. So angle X, right here, is congruent to, let's do 2 tick marks on that, with angle R. All right? Angle Y was congruent to itself, angle Z, and angle S. Those two are congruent with each other. All right, so now we can take the sides. Again, this is where people mess up when they do the sides, because people want to say XR. Well, XR is not a side of the triangle, okay? So be careful about that. So let's take the first two letters. That's why the similarity statement is going to be much more helpful to you. So XY, that's the first two letters in the whole big triangle. That side is proportional to RY, okay? So we're saying this entire distance right here is proportional to this small distance. This is going to be important because we're going to solve problems with this in just a minute. So XY is proportional to, or XY over RY gives us a ratio. All right, that ratio is equal to YZ over YS. YZ over YS. And then finally, XZ is proportional to RS. Have to look at the first one there again. Okay, so those sides are proportional. 3. Let's do one more. If you need it, if you don't need this, hey, well, everybody needs this one. This one's a quadrilateral, not just a triangle here. So you notice we've got places for 4 angles. So we've got places for 4 angles. I don't know why I just did that. So we'll erase it. All right, here we go. Congruent. Don't know where that less than or equal came from. All right, so angle J and angle Q would be congruent. Angle K, angle R, congruent. Angle L, angle S, angle M, angle P. All right, not even going to mark these on the 2 diagrams. You can put tick marks on those if you want. All right, now downward, since we've got a quadrilateral, this is going to have 4 sides, so therefore you're going to have 4 fractions right here. So 2 letters apiece. So just be careful here. JK, QR. All right. I would just go first and second, second and third, third and fourth. You know, you can mix these up in here. Let's do KL to RS. Okay. I'm just going around the horn here. LM and SP. And then finally, the last one and the first one. So that would be JM and QP. So, you know, you don't have side JL because JL goes through the figure right there. So I'm just basically going around this shape. J to K, K to L, L to M, and M back to J. So all of those sides are proportional, and all of those angles are congruent. All right, so here we go. Let's do some problems with these. Finding side lengths. All right, you know, the cool thing about this that you can't do in class is you can just turn me off. I guess some of you can still do that in class. You probably still turn me off in class, don't you? But you can turn off the video, take a break, and come back to this. So let's use proportions to find these missing side lengths, okay? So it says if the figures below are similar with a scale factor of 2 to 3, find the value of x, okay? So the scale factor is 2 to 3. Now, here's where it's kind of helpful to think about what number came first in the scale factor, what number, the size of the number that's first and the size of the number that's second, okay? because that's going to help you set up this proportion. I mean, this is going to look like this, a fraction equal to a fraction. Well, I've got 42 and x. Those are corresponding sides, and here's the scale factor, okay? Well, if you look at the diagram, x looks like it should be larger than 42, okay? So on one side, I'm going to put the scale factor. I'm going to say 2 over 3. I'm going to write 2 to 3 as a fraction, 2 over 3. And if you pay attention to, numbers right here, if the top number is smaller than the bottom number, then over here, the smaller number should be on top as well. So we think 42 is going to be the smaller number. So that ratio should look like that, 42 over x. You say, how am I going to know that? How am I going to know how to write this? Well, again, if your first number is smaller than your second number, then you should look at your diagram and see which sides are going to be, which number is going to be smaller, which one's going to be larger. I think you're going to be able to tell that pretty much at all times. So 2/3 equals 42 over x. Remember how we solved these yesterday? We cross multiplied. So 2x is equal to 126, and then divide by 2, x is 63, okay? It's pretty easy, isn't it? Because 42 over 63 is still in the ratio of 2 to 3. All right, if the figures below are similar with a scale factor of 6 to 5, okay, check that scale factor out. This time the first number is larger, okay? So when I write my proportion and I say 6 over 5, this time, so I'm going to put my larger side over the smaller side. So if x and 28 are corresponding sides, the x needs to go on top because on the left side, the larger number was on top, okay? It's a pretty simple way. Once you get that down, you shouldn't have problems. You won't even think about it. So 5x is equal to 168. That's 6 times 28. Obviously, this is going to give us a decimal answer. This is going to be 33.6. Okay, again, rounding to one decimal place. Okay, number 6, if triangle ABC is similar to triangle DEF, find the value of x. So notice this time they did not give us a scale factor. So we need to kind of figure out where the proportional sides are for this one. So they didn't give us a scale factor, but we do have 3 numbers and an x. So again, this is not just a random placement of the numbers. Doesn't matter where they put. It doesn't matter where we put them. We can put them anywhere we want and get the right answer. It's true that they can be written in a couple of different ways, but they have to be written correctly. So let's start with, it says triangle ABC. So notice we have side AB. So side AB is x, and side AB, the first 2 letters, is going to be proportional to side DE. Aha. So if I'm going to put 25 on the bottom. So that's comparing 2 sides that are corresponding. Corresponding sides right here, x and 25. That's AB and DE. All right. Then on the other side, notice since this x came from this larger triangle, we need to put 28 right here because it's got to be consistently written on this side. So in other words, large triangle to small triangle, large triangle over small triangle. And we would, even though we know we're going to put 20 there, check it out. This is side BC. That's the second, third letters. So we know it's proportional to EF over there, which is 20. So that's pretty important because if you put 20 over 28, you would not get the correct answer right there. So here's what we got. We got 20x is equal to 700. 28 times 25. Divide by 20, x is equal to 35. All right? So this side would be 35. So 35 and 28, 25, and 20, those sides are now proportional. All right, 7, PQRS, similar to WXYZ. Find the value of x. So let's see if we've got sides here. By the way, this should never happen in a problem like this, but could you possibly see a problem where they give you 3 numbers and an x value, and those are not really the corresponding sides? I guess that's possible, but highly unlikely, okay? because otherwise you really can't solve it. So let's see what we got. We got, I like to start with my variables. So x, I'm going to put x right here, but x really could go anywhere depending on how we write it. So x is rs. So that's the last two letters. So that should be proportional to zy, all right, which is 32. So x over 32. So since we started with this bigger quadrilateral on the top with x, we should put the 75 here and then the 40 there. And again, those two sides, PS, that's first letter, last letter, should be proportional to WZ. And see, WZ was where that 40 was. All right, we're going to cross multiply and solve for x. By the way, if you are noticing what's happening here, as long as you show me this setup right here, I'm really okay with you taking your calculator and multiplying the 32 times 75, because you know that's going to happen. And then we're always going to end up dividing by the coefficient in front of x. So if you want to multiply these two dudes together right here, and then just divide by 40 in your calculator and tell me what x is, I am all about that, okay? Because you've shown me the proportional setup. The rest of this is just multiplying. You won't be able to do that except on these kind of problems. Because once you start having more complicated expressions other than x, that's not going to be wise to do that. But here, since we just have x and three numbers, that's pretty acceptable. Okay? Okay, this is a little bit longer lesson because we've got 3 pages to go over. Here are the harder, more difficult problems. This is one more, just like the one we just did. So, but this one has an x and a y. So with two variables here, you got to be careful. You don't want to set up a proportion that has x and y both in it, okay? So what we would like to do is over here use two of these numbers, either 9 and 14 or 9 and 12 or 12 and 14, and then x and 15 or y and 15. We don't want to set up a proportion that has x and y in it. That's going to be a problem. Now, could I write one like that? Yeah, let's see. Let's just for grins see what that would look like. GH would be last letter, first letter, so that should be matched up with FD. So that would look like this. X over 12 is equal to GJ, second and third letters EF, so that would be y over 14. That is a mess, okay? You got two different variables and you can't solve it that way. So let's pick our proportions wisely here, okay? So let's start with x again, all right? So we know that x is going to be matched up with 12, but we don't want to use y and 14. Instead, we want to use the other two. So that should be 15 and 9, all right? So 15 over 9. Again, those match with the similarity statement up there. So I started with x in my big triangle, and I said x compared to its proportional side, or its corresponding side. So GH, that was first and third. So over here I should be looking at FD. So FD was 12. So those two guys right there are proportional. All right, and then again, starting back in the numerator with the big triangle, 15 over 9. So 9x is equal to 12 times 15 is going to be 180. So x is 20. Here we go. Now let's set up a proportion with y. All right, so y is GJ, that's the second and third, so that should be proportional. So we would say y over GJ, that would be these two guys, EF, inside EF is 14. So y over 14 equals, now guess what? I could still use these 15 and 9. Or I could, since I know that x is now 20, I could say 20 over 12. I got my choice. Let's just stick with 15 over 9 again. All right, again, this is one that you can do this in your calculator. So you know you're going to multiply 14 times 15, which is going to be 210. So 210 divided by 9, then again, that will tell you what the answer is. It's not going to come out to a whole number. 23.3. So 9y is equal to 210. And there you go. All right, you should be kind of getting a feel for these. Maybe this one, maybe this it's not quite so difficult anymore, right? Check this out. If JKL is similar to NML, so we're saying these two triangles are similar to each other, okay? So that means this big angle J down here is congruent with this angle N. We already know that these two dudes in the middle are vertical angles, right? And so that would leave this angle K and this angle M to be the congruent angles. So again, this is another way you can help identify what your corresponding sides are by looking at what angles they are between, all right? So let's start with X, okay? So X is between the 2 and 3 tick marks, so that should be proportional to 14, all right? And 16 and 40 should be proportional to each other. They are between the 1 and 3 tick mark, the 1 and 3 tick mark. So the question is, does it matter which way I write it? And the answer, of course, is yes, it does matter. So since X came from this larger triangle, we should put 40 on the top and 16 on the bottom. Because again, we're going from large triangle to smaller triangle. We want to be consistent, large triangle to small triangle. So cross multiply and divide, 14 times 40 divided by 16, X is going to be, X is going to be 35. X is going to be 35. Let's erase that. Okay, X is 35. All right, let's find Y. So proportions to fractions. Okay, I want to start with Y this time. Y is in the small triangle. It's one of the sides of the small triangle. Notice it's between the angle with 1 and 2 tick marks. So that would be proportional to 45. So this time we're going from small to large. So we can go from small to large on the other side, and it doesn't matter if we say 14 and now we know this is 35, or we can say 16 and 40. I'm going to use 16 and 40. Okay? So notice how these two fractions, 40 sixteenths and 16 over 40, those were the same numbers, but written in different order because of how we began with the proportion. One side of that ratio has to equal this one. You have to be comparing apples to apples here, all right? That could be the name of a game, couldn't it? So 40y equals 45 times 16. Again, cross multiply and divide, y is 18. If we were together, I'd say, hey, turn to your partner and see if you can do number 10 together, all right? This is the last one. Well, I take it back. This one's got a little different thing here, doesn't it? X plus 6, X plus 3. Well, that's not going to change how we set them up, okay? So here we go. We got the similarity here, AGM and KXD. I don't usually take the time to mark my triangles, the angles that are congruent, but if you liked that better in number 9 so that you can identify which sides were proportional, you be my guest, you can do that. What I'm going to do is I'm going to say XD, that's side XD is X plus 6. And right up here, XD was the second and third letters. So that should be proportional to GM, which is 36. All right, and then the other side is X plus 3. That's in the small triangle again. Well, X plus 3 is XK. That's these two guys right here, X and K. Well, that should be proportional to AG, which is 32. All righty, okay, here we go. Remember now we're going to have to go cross multiply, and we're going to say 32 times X plus 6 equals 36 times X plus 3. By the way, let's talk just a second about this, because some of you may be tempted to do this. All right, if you have this, guys, you know that you cannot do that and reduce. You cannot. No, 1,000 times no. Okay, we cannot reduce like that because this X plus this 6 is part of a sum on the top. The only time you can reduce is when you have factors in the numerator and denominator, which means multiplication. So this is certainly not multiplication. So don't attempt to reduce like that. Okay? So we're going to have to distribute here. This is 32x, and 32 times 6 is going to be 192. On the other side, 36x, and then 36 times 3 is going to be positive 108. This is going to be a snoop full of algebra in this lesson, isn't it? Okay? So here we go. We're going to subtract 32x from both sides. That's going to leave me a 4x there. Now we're going to say minus 108 from both sides. So if I take 108 away from 192, that's going to leave 84. So divided by 4, x is going to be 21. And we are rolling in the fudge. I have no idea what that means. Okay, 11. If TLY is similar to CKX, CHK, I mean, find LY. All right? So we're just looking for LY. Let's make sure, did this one say, yeah, this one just said find X. So find LY. Well, we need to know what X is. If we knew that, we can just plug it in, multiply by 4, subtract 1, and move on. But we don't. So let's set up a proportion here to solve this. All right, so I'm going to start with 4x minus 1. So LY, these are the last two letters. That should be proportional to HK, and HK is x plus 5. All right? I know on the other side, since I started with 4x minus 1 in the top, that I want to start with 25 in the top. All right? If you're just looking at these and not watching the videos and listening, that's where you're going to probably mess up because you're not going to know where to put those. All right? So, moral of that story is watch. All right, now, here's a case where we can reduce. Over here on the right side, 25 over 10. We can reduce right there. 5 goes into both of these numbers. 5 goes into 25 5 times. 5 goes into 10 2 times. You say, why in the world would you want to do that? Well, I'd rather multiply by 5 and 2 than 25 and 10, honestly. I'd rather distribute those. Because see, now you're going to have 2 times 4x minus 1. And then over here, you're going to have 5 times x plus 5. So here we go. Isn't that a lot easier to distribute 2 and 5 rather than 25 and 10? So that's ax minus 2. This is 5x plus 25. All right, subtract 5x from both sides. That's 3x. Add 2 to both sides, 27. Thank you very much for giving me a whole number. X is 9. And then now we can find side LY. LY is going to be 4 times 9 minus 1. And that's 36 minus 1, or 35. Bingo lingo. That's what we wanted right there. All right, last problem. Last problem. All right, if B and V is similar to BRG, so we're saying this little bitty triangle is similar to the entire triangle. Okay, ooh, interesting, huh? All right, and BR is 4x minus 7, and BG is 18. If you can't draw those little squiggly brackets, that's okay. Just draw like a big loop there. Find the value of x. So I like this problem because you really can see the proportional sides here. 12, the distance from B to N, 12 is proportional to the whole thing, 4x minus 7. And 8, this little part of the bottom side, the bottom leg of this triangle, is proportional to the whole thing, which is 18. So it makes setting up the proportion pretty easy. You just got to be consistent. Let's start with the little dude. 12 over 4x minus 7 is proportional to 8 over 18. Okay? Now, you might be saying to yourself, well, what if I started with 4x minus 7 on top? Well, if you did 4x minus 7 on top, you would just take both these fractions and just flip them over, and guess what? You'd still get the same exact answer. So 8 over 18, I like reducing when possible. 2 goes into both those numbers, so that's going to be 4/9. All right, let's cross multiply. So 4x minus, I got 4 times 4x minus 7. You guys who know how to distribute by just looking at that, you can probably avoid writing this step down. So that's going to be 16x minus 28 equals 108. All right, let's add 28 to that. Okay. So I got 16x equals, that's going to be 16, that's going to be 3, that's going to be 136. So 16 goes into 136. That's not right. Is that right? That ain't right. 16x minus 28 equals 108. Yeah, that is right, 136. So, something ain't righteous. 12 over 8. Oh, 12 over, still, I'm distributing right. 4x minus, oh, it's not 4x minus 7, it's 4x plus 7. Okay, I did that on purpose. I was just seeing if you all were paying attention. You have to be careful how you copy the problem down, because I did not copy the problem down correctly. Okay. Before you get the main hall. Now 2 more. 2 more. 2 more. All right. Sorry about that. My wife is with me. This is actually Saturday afternoon, and yes, I'm a nerd doing math on Saturday. But she is with me, and she was looking for the ladies' room. The ladies' room. All right. So let's try this again. 4 times 7 is 28. Over here, this is still 108. All right. So I'm going to subtract 28 from both sides. So 8 minus 8, that'd be 0. 10 minus 2 is 8. Guess what? That feels a lot better. X is 5. There you go. Done. Stick a fork in it. Okay? All right. So you say, what about these next 2 pages? Do I have to do those? No. These are purely for your own practice. If you feel like you need some additional practice, here's what I'd do. I'd say, if I'm not getting the homework right, because here's the homework. If I'm not getting the homework right, maybe go back and try some of these just for a little extra practice. Or you can just leave. Don't even do these, okay? Whatever you want to do there. If you're struggling with that at all, please send me an email or a remind message, and I'll be happy to kind of walk you through that, okay? All right. Talk to you tomorrow. Have a great evening.